Okay, we're gonna do just a tiny bit of review from last class. So this is actually where we are composing and we'll say evaluating. I just want to show an example, just a reminder of where we are at. Okay, so I'll give you f of x equals, 2 root x, and I'll give you, we'll just say h of x equals x squared plus x, and g of x equals 1 over x plus 1.
Can you give me like 1 second?
Sure. Okay, here we go. We have F, H, and G. So let's look at an example. All right, I want to do H of F of X. That's what I want to find. So H composed with F. So I'm going to write down, right, this is sort of like the way that I'm going to help visualize the composition where I'm putting these two things together. And then I'm going to look at this. I'm like, okay, I need to take F, right? And it's going to go into, oh, that's a little different. It's because I have two X's. It actually goes into both of them because it's replacing the input. It's replacing all of the inputs. So when I put this together, it's going to look like, I'm going to leave a blank up there for the answer. It's going to look like this. See how I substituted in both of those places? If you had more than one, right, it went into both of those X's in the H function. And then in order to simplify, see that square there? A good thing to remember is write it twice, right? Multiplied by itself. And so I'm actually just going to write the parentheses piece twice, and then I'm going to multiply it. Okay? Because I don't want you to lose the foiling that you may have seen in some of the homework. Because you had the parentheses, it ended up with foiling. So here, I'm just going to 2 times 2 is 4. Root x times root x is x. And so that is the answer, 4x plus 2 root x. Okay, one other piece here. We're going to do a little evaluating review, and then we'll move into the points in the tables a little bit. Okay, so I want you to find, H of G of f of 9. Whew. Okay. H of g of f of 9. So in order to help me with yeah, you can do it, right? It's just one step at a time. So I'm going to write that. You kind of look backwards in your notes and see if you can't figure out what it is. I'm going to give you some think time here. Okay, question?
You're missing a parentheses on the right side.
Thank you. 1, 2, 3. You are right. Okay. Another question?
So if we were to use X for every step of the process, and then plug in 9 at the very end, would we
That
just
works
as
also.
plugging in 9 at the beginning?
Yes. So that is definitely two ways to approach the problem, and it really doesn't matter which way you do it. You will still get the same result. Yes, it's okay to have fractions. Do not use your calculator for arithmetic. We don't use calculators in this class until maybe second quarter. Okay. So I'm just gonna start. Okay. And then this whole thing goes in here. Okay. And then this whole piece, all of it, actually has to go into two places. Okay. You can kind of do this like one step at a time, or you can put it all together. So, all right. Because this question was asked, I'm going to show it both ways. So, oh my gosh. All right, I can do it. Okay, so there's the composition, right? I just put it all together and I kind of ignored that last step. Okay, I ignored the 9. That's okay, right? If I put the 9 in, it looks like this. Okay, 2 root 9. Okay, 1 over plus 1. Okay, squared. Plus 1 over 2 root 9 plus 1. Okay, it doesn't matter where you plug the 9 in. You can do it with the x's and you can do it with the 9's. Now, PEMDAS, work your way inside out. So I get 1 over 6 plus 1 squared. Okay, so this ends up being 1 over 7 squared plus 1 over 7. When you get a square, I'm just going to come up over here. It's multiply by itself. When you multiply fractions, you go straight across. when you add fractions, you need a common denominator. I'm almost certain this is maybe something that has been lost over the last 2 years. Okay, so I'm going to multiply this thing by 7 over 7, which is called a fancy form of 1. Okay, the reason 1/2 is equal to 2/4 besides duh. Okay, 1/2 equals 2 over 4. You're like, yes. Okay, why? Why?
If you multiply the top and the bottom of the C number, it's the same thing.
Yes, they're equivalent. This is called a fancy form of 1. As long as you multiply by 1, it's called the multiplicative identity. Like, oh, those words, they mean something. They do. You multiply by the multiplicative identity, which is 1. 1 times anything is itself. Okay? Then you get an equivalent form. So I take 1 over 7 and I multiply this fancy form of 1 called 7 over 7. I end up with 7 over 49. Now I have a common denominator. Okay? So I'm a little bit out of room here, so I'm just going to add a little index card here. So now I have 1 over 49 plus 7 over 49, which means I now get 8 over over 49, not 48. Woo! 8 over this. Blah, 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 blah. That's it. You're like, that was a lot of writing. It was. But you can do it. Okay, I'm just going to tuck this in here. Now, I'm going to show you something. Are you ready? Okay. I'm going to kind of cover up some of the work I have here. And I'm going to do this one step at a time. So when 9 goes into this part, because I can do this part in my head, I get root 3, I get 6. Good? When 9 goes into this, I get 6. When 6 goes into this, I get 1 over 7. Way nicer when you do it one step at a time. When 1 over 7 goes into the last part, I get 1 over 49 plus 1 over 7. Yeah. It is much easier when you can break it down and do one level at a time. But what I did is I did PEMDAS. I just did it without the writing. Okay? I did it in order. I started on the inside. So watch this. 6 is the first number that I got. 6 to 1/7 to squared. It was just with a lot less grouping symbols, but it's the same thing. Okay? So just be careful on how you set up the work and just make sure you have a confident way to do the problems. Okay, so I'm going to leave that little post-it here. Okay? If you want index cards to write alternate things in your notes, then just tape them in so they can fold, right? So you have more than one thing to look at. Go for it. It's a good way to add little pieces to your notes or post-its where you just stick a little extra thing in there. Yep, come grab. That's why we have them if you want them. I'll leave a stack here. I'll leave a stack and just put them in your bins. Okay? Go for it. All right. Remember, you are going to get some work time to look back over this so that you can take any extra notes you need to. All right. 1, 2, 3. C? B? I don't know where we are. B. Thank you. Yep. Tables and points. Okay, tables and points. Which is really just examples. It's just different types of examples.
Is it still,
So yeah, still 1.3. We'll call this one f of x. So instead of me giving you equations, I'm just going to give you a set of tables, okay? Which is really xy coordinates, okay? Okay. Okay, so I'm still setting this up in a very similar way. I just don't have any equations to write here. I just have F and H, which are tables, which is really just points. Could they be a graph? Yes, a graph is just a visual of all the X's and Y's that go together. Okay, so right here, H, okay, -2 still needs to go into H. Okay, well this is H. So right here, I'm going to write the point -2, 2, because that's the point I have. Yes. Yeah, just 2 points. I could list a whole bunch of points, but we only need a few to work with. Okay, so if -2 goes into H, what comes out?
-4, -4.
It's positive 2, right?
Yeah, it's +2. Okay, tell me why. Tell me why.
Because -2 is the input, so positive is the output.
Yes, input, output. -2 goes in, +2 comes out. +2 comes out. Input, output. X coordinate, Y coordinate. +2 comes out. Whew. All right, next level.
So it'd be
2 goes into F.
so it'd be 2, -1.
2, -1. It's like a little chain. Composition is linking inputs to outputs.
But it doesn't affect the line at all.
No. So
But
this
those two lines-
this middle step here, this output is becoming the next input because it's going into F. All right, so what do we get? We get -1. So -1 is the answer. Now I'm gonna see if I can. I'm gonna highlight it on my table here. Okay, here, I'm gonna show you. So here you go. There's my starting point. You ready? There's my starting point. -2 is where I start on the H function. All right. That brings me to 2. Where does that go? Well, it has to take me to the F input.
Nice arrow there.
Yep. Okay, input, output.
Oh,
Yeah. Okay.
That'd be so
okay.
Composition is hard to explain, easier to see, sometimes tricky to actually do the problems because it inputs turn to outputs. It's all kind of connected. Okay.
Is this gonna be on our test?
Yes? On Friday. You have more time. Okay, here we go. I'm going to give you one. Let's try again. Let's do find G of H of -1. So we are connecting X's to Y's, X's to Y's. G, H. I'm going to set up some work without you being able to see it. I want you to try it, and then I will show you what I did.
Mr. Reach, I think I got it.
Yeah.
Doesn't matter which one you
Yes.
how do you know which one?
You have to start. Oh, you can't see it. Okay, you have to start at the x coordinate of -1 on H.
I don't know why this literally I'm like this.
I can explain.
It's the same.
That's
It's the
awesome.
same table before.
So it's
Okay, we have 5 minutes to lunch, and the answer is 5. Yes, okay. So I sort of did it 2 ways. This goes to here, goes to the output, then that becomes the input, and the answer is 5. So I wrote it horizontally this time, right? And I did it in order. So when you're evaluating PEMDAS, you always start inside. So -1 is the starting point. So next I go to H, and that goes -1 to 3. Then I go to G, and that's 3 to 5.
Ooh, I got it right.
Yay! All right. Okay. We are going to go ahead and I'm going to show you one decomposition example, and then it'll probably be lunchtime, and then we'll just practice when we get back, and then
Writing the problem down?
yeah, we're going to write it down.
It's so cool.
Okay. C. Decomposition.
Should I change pages? Or
No,
no?
I just write really big, and I like to scan it, and it's easier this way. Okay.
Yeah, I'm just writing it. Look, this is what I did. I wrote a line, then I did that. I just used the 2 lines to, guideline.
Yeah, but like I still can't.
That's so good.
I still can't let up steady.
Oh yeah, I know.
There's no way you're gonna. Yeah, it's still wavy though.
That's what
Okay.
I did.
Yeah,
So we are going to.
Can I go grow? Oh, I just read it. Decomposition. I'm gonna stop class for a sec.
Okay, we're going to break apart the functions into separate operations. Operations are things like PEMDAS, add, subtract, multiply, divide, exponents, which is like powers, PEMDAS. And our goal is to do one operation per function. Okay? One operation at a time. So remember that we were doing like one step at a time. I only want to do one operation at a time for the functions. Okay? So here we go. Examples. Given. Oh boy. All right, I gotta think. Okay, so f of g of h of x. Okay.
Fun.
I'm gonna give you the composition. You're gonna have to break it apart into the 3 separate functions.
Oh.
Now, I'll give you a little starting point, possibly, okay? So you have to look at how to break it apart. F, G, H, okay? So I have to make sure I only give you 3 functions here.
Mr. Reese, you list your parentheses.
Ah!
Our answer is a fraction? Yay.
That actually makes it easier than you think it does.
Oh, it does?
Yeah.
Nice. Thank you.
Uh-huh. Okay. All right, so I'm going to tell you that I'm going to give you the starting point. Okay, I'm going to tell you that h is equal to x minus 1. You have to envision, what is this going to go into? What is this gonna go into so that when you get to the top, you've got the composition. But you can only add one operation at a time. One operation at a time. So, like square root. Okay, so now that I have the x minus 1 inside the square root, now I need it to be in the bottom of the right, one thing at a time. I can't add the fraction in the root. All right, see you after lunch. Our practice includes our decomposition, so don't worry, you'll get a chance to perfect it. It's okay. Okay, here we go. This one just says find f of x squared. So that's x squared going in here. So that's minus 4x squared minus 1. Okay, I know this is question 1. And let's see, we can type that real quick. Minus 4x squared minus 1. Oop. Okay. All right, and now it wants me to find the g composed of that. So it would be 2 minus 4x squared minus 1, parentheses, minus 2. And then it wants you to simplify. I'm not simplifying, I'm just showing you how to type some of these things. Okay, now this one's a little bit funny. You're like, I don't quite understand what this is saying. Notice here that it says the composition equals this. It's all about how you translate the information. So if this is the composition, I need to know what F and G are. Notice that it told me G. I would try to set up your composition in a similar format to what we do in our notes to help explain and show you what information you have. This is what they're asking for. Now you can use more than one operation. I was just suggesting you start with one operation at a time so that it's easier to pick the pieces out. But this would go into F, which is 1 over x squared. Okay, so 1 over x squared. Okay. Oh, now, same composition, but they're changing it around. This time, they want F to be 1 over x. Right? You can compose things differently and end up with the same result. So what would have to go in? It would be this. Okay. X minus 8. Oop, that's not it. Let's try that again. X minus 8, shift, squared. All right. Continue. Okay, this one's a little bit tricky because you've got lots of different pieces here. So this is the composition. H of x is F composed of G. And F is something, and G is x minus 9. Okay, G is going to go into this one, and the result has to be that. So look at everywhere that has the x minus 9. That's where it's going to go in. What's left? X cubed plus 3x squared plus 8x minus 5. F again, so look up here at the composition. Okay, look at the blurred out pink parts. What's left? Right, because G is the pink part. So take the pink part out and make it an X because that's what's being replaced. And that's how I came up with F. It was sort of like, what's the in-between part? Take away the G and see what's left to be the F. Okay. Or, oops, sorry. Whoop. Or, ooh, all right. Let's see. I've got the composition, which is this. It kind of looks like, oh, the same thing as being, okay, let's see if I can do this. F and G. All right, so I'm gonna actually put this part in pink, and I'm gonna put this part in pink to help me recognize it. So if that's replaced, that leaves me with 7 plus the pink part. They actually happen to be the same thing, and that's okay. You can compose 2 of the same functions. All right, word problem. Okay, the only reason I wanted you to see most of these word problems is to just kind of interpret them. And so here we have the composition. Notice that the input is S. The input is B. So let M of S represent, okay, M and S. Number of bricks. Okay, so this is number of bricks. I'm giving these things titles. And with the surface area, nope, this is number of bricks. Okay, I'm gonna make sure I do it right. This one is surface area. Okay, C of B, so B and C represents the cost. And this is bricks. Actually, I think I was backwards here. Let's try that again. Let's try it again. S, M. S is the input. Surface area, number of bricks. Okay, B to C. Oh, number of bricks. Do you see the connector? Output becomes the input. Cost. Okay. So, no, I'm not going to test you on word problems. Not on these. You will get better at them. Okay, so the input is surface area represents the number of bricks. No, we want the cost with the number of bricks. This one, you want the cost with the number of bricks. Surface area is the connecting piece there. Okay, guys, I do want to, okay, I guess I could try to quickly do these. Actually,